Good afternoon, ladies and gentlemen. From my side, it's a great honor to be here. Thank you so much for the kind invitation by Mr. Stam Achillas, also the organizers. I've been speaking around the world in such events, and I have to say that this one is a particularly well-organized event, so congratulations to everyone who is involved. And I would really, I'm really impressed by the translation. Because I have an engineering background and I'm Greek originally, but I would really very much struggle to do your job in Greek, to translate immediately from English to Greek with this very highly technical matter. So really, congratulations. I have brought also my trusted translation equipment with me, so feel free to ask questions in Korean after I finish. So I usually speak about fitness, and it's not about personal fitness, it's about how to keep fleets fit for the future through retrofits. And at Wärtsilä we have a really broad range of retrofit solutions to keep the current fleets, the existing fleet competitive. And it ranges from, of course, our focus is in engines, a lot of focus is on engines, so we talk about engine efficiency upgrades, we talk about fuel conversions, but we have so many other solutions to offer, like propulsion or electrification, or carbon capture, even wind assistance. So there's this broad range of solutions, but in my area of the business, we are focusing on two-stroke engines. So retrofitting existing two-stroke engines to either be more efficient or be converted to different fuels. And a bit of history about our organization. Some of you may know that Wartsila two-stroke used to be an organization that also had a new building. We were designing also new building engines. But then Wärtsilä, that Mr. S9-5 is part of, split off, and when they did that, they also took with them the R&D capability. So the whole R&D team developing these engines and technology. So back then, in around 2015, we were a small engineering team focusing on service and spare parts and troubleshooting of engines. So we had something around 20 engineers in Switzerland, and a very small portfolio of retrofit solutions, which were focusing on efficiency improvements. And this was also what the industry was ready to accept and also invest in, because all these efficiency upgrades had to do with improving fuel consumption, and the payback time and return on investment was always calculated investment versus fuel saving. Now in 2019, and this was the situation up to 2019, when decarbonisation came to disrupt everybody. And then we were given the mandate to grow a business to look into retrofit solutions, really larger scale retrofit solutions for two-stroke engines, because it is obvious that we need to do something about the existing fleet. I'm lucky that the previous speakers were talking about all this, the pathway of fuels. So we see more and more dual fuel engines, more alternative fuels coming into the market, but we are still building half of our ships to run on diesel, almost, right? And we have so many thousands of ships out there that are only mono-fuel, or capable of burning only one fuel. So to help these vessels along and keep them, extend their lifetime as much as possible, we started developing a team that develops all these solutions that you see here, an even broader portfolio of solutions. And the dark bubbles are all efficiency upgrades, meaning to improve the efficiency of the engine, and so that it consumes less fuel, and of course has a smaller carbon footprint. And the orange solutions are fuel conversion solutions to convert the existing engine from a diesel engine to burn either LNG or methanol or ammonia. And to do that, we also had to grow our organization. So in the last 5 years, we went from 20 engineers to over 100. And we also have a test center in Trieste, Italy, where we have a full-fledged test engine to perform our development. Now I will go. I will show you an example of a solution which is the one that brought us to the large retrofits. It was the first solution that we consider a large retrofit solution. So this was targeted on large container ships that were designed back then for a market that required very fast container ships. So ships that were sailing at 27 knots or so. And then we developed this really large bore and powerful engines, the S9-5 engine, for this purpose. But it was a short-lived market. So now the same vessels are sailing below 20 knots. And this means that these engines are also operating at a very low load point, so below 40% of their original power, making them very inefficient. So to solve this problem, we devised a solution to let's say exchange all the upper part of the engine from the crosshead up to reduce the bore size from 96 centimeters to 72. So as you can see from this let's say animation here, all these parts are new to the engine. And effectively how this works is, first of all, by doing this massive power reduction, we're reducing the engine power by up to 60%. So the resulting engine is only 40% of the power of the original. This means that we are running at a much more efficient area of the operating range of the engine. And this is also, all these components and technologies that we install are 15 years more advanced than the original engine. And this brings massive savings with it. So we're talking about up to 15% efficiency improvements or saving 50% of fuel. And as a bonus, as you may have seen from the animation, the engine is also ready to change the fuel, because we have additional holes in the cylinder cover, which allows the installation of additional injectors. So this is preparing these engines for the future as well. Then a lot of text. I will share this for you to read later, but let's say the key message here is perhaps that we have already delivered 12 of these vessels. The first one was delivered 2 years ago, and it's 2 years in operation. And we have another 15 on order and a few more in discussion. And we can convert these engines in 2 to 3 weeks. This means doing it within a scheduled special survey. So we don't require an additional off-hire of the ship. We can do this job within a scheduled dry dock and deliver the ship on time. So we have done this already many times. But this also required, this was, as I said, the first large-scale project that we did, and we learned a lot from it. So for the first project, we have strained, we have reached the limits of our supply chain and also what our organization can do. Imagine that we had to deliver around 20 containers of parts, for this happening. This is what goes on every other project. So we had to adapt the supply chain to this new reality. We had to develop teams that deliver these projects. We have now a very capable team now project services organization that does that. And also had to develop new techniques and processes. For example, all these engines need to be NOx certified after this process, but we cannot do that anymore on the test bed. So we had to do a factory acceptance at sea, shop test at sea, as we call it. This we have developed a process with all the major classes, and we have done this successfully even with the EPA in the US, which is the most strict. And we are confident also that we can do it with any class. And this also paves the way for the next wave of retrofits, which for us will be the fuel conversions. Now, this is also one of the few retrofits that you can get a guarantee about. Because, for example, many owners are investing in bulbous bows or propeller optimizations or coatings. But we hear the complaint that although they invest all this money, they don't know exactly how much it moved the needle, how much they have improved the situation, how much fuel they're saving specifically from this solution that they invested in. And what is different with our solution is that we can measure the engine before the conversion, the specific load points, and we can measure it after the conversion using our, let's say measurement protocols that we developed for this purpose. And we can prove the saving. And this is an example of one of the vessels we converted last year in June, where we derated the engine by 60%. We also replaced the remaining turbochargers with a smaller frame size. They were Accelerant turbochargers, so we worked very closely with the Accelerant team and managed to produce this result, which is a 13% efficiency improvement, also confirmed by the owner. Now, I talked about the next wave of retrofits, which is the fuel conversions. And there, we have what we consider a pragmatic approach to it. We only remove the cylinder cover of the engine and exchange it with a cylinder cover that has additional holes to install the injectors. So the base diesel engine remains untouched. It has the same power density, the same rating. We don't create the engine in any way. And everything else is an add-on. So we even have our, let's say, basically if we look at the methanol injection system, here everything is an add-on to the engine. We even have a dedicated control system for this injection system, which means that we don't care what is the version of the engine control system or what the type, and we don't rewire the whole engine to make it fuel capable. We just add the control system together with our injection system. And this is, because we know how complex retrofits are, and we want to make it as simple as possible. Also, not, let's say, changing anything on the diesel engine, because we know the diesel engine should be always the basis for any sort of conversion. It shouldn't be compromised in any way. Now our system works with low pressure all the way up to the injector. So from methanol we go with around 16 bar, or let's say below that, the design pressure all the way up to the injector, and we're boosting the pressure in the injector using hydraulic energy from the engine itself. Again, this is our approach of being pragmatic about these retrofits. We try to avoid installing external power to the engine, because we're talking about existing installations. So we don't want to strain the auxiliary engines more with additional power. And we use as much as excess energy as is available from the diesel engine to run all the processes on the engine. And then the injection is 600 bars, so we're talking about diesel injection. And all our fuels will have the same diesel cycle injection. So LNG, methanol, and ammonia will be at the diesel principle. So, anyway, for methanol, if the video plays. There should be a video here. Okay, this was about our test facility in Trieste, where we had an event earlier this year in May. We invited around 35 customers from all over the world. Unfortunately, the video doesn't play here, but you could see that we had let's say we had our test engine running and a display where we demonstrate all the engine vitals. And there we also managed to show to our customers firsthand the performance of the engine, which is quite, let's say, competitive and even superior, I would say. Although this was a diesel combustion, our development team has started from scratch. Started from a spray chamber together with the University of Turin. And they were working in parallel in 3 locations in the University of Turin, in Trieste, the R&D facility in Trieste, and also in Fraunhofen, where our main R&D team is, in Switzerland, and developed this combustion model for methanol that we saw later on in reality brings quite a huge saving. It's much more efficient than diesel combustion. These are measurements from the engine, from our test engine that we could demonstrate also to our customers in last May. And you see that if we correct for the lower calorific value of methanol in this graph, methanol has 4 to 10 grams less fuel consumption, so it's a more efficient combustion. And this was all done with 40% less NOx. So if we also correct to the tier 2 NOx level, the fuel efficiency becomes even better because it's a trade-off. Then a huge element of our interaction with the customers is about understanding what they're trying to achieve. Because decarbonization is, we don't believe that anyone will invest in decarbonization just to be greener. They have to have more competitive ships as a result, more competitive fleets. And this can mean many things for different customers, right? They might be able to sell these green tonnage at a higher price, or they might just want to be compliant, or they might want to use this EU trading system to bank this green, let's say, credits and use them elsewhere, or have a pooling effect on their fleet. So there is no silver bullet solution. We never approach our customers telling them that we know what is best for them. We have to really sit with them and identify what is their decarbonization target when they're looking at the lifetime of the vessel, and even put a value to this, to understand what is the value of this decarbonization trajectory to their business. Why does it make them more profitable? And then talk about solutions, right? And the solutions can be from the broader Wärtsilä portfolio, and sometimes we will have to work with other companies, with other companies that might be considered even competitors. We have examples of a project where we optimize the efficiency of the engine and work with Accelera to also optimize the turbocharger, and work also with MAN Energy Solutions on the same vessel, where they had the propulsion system. It was a controlled pitch propeller, and we brought to the customer an amazing result. So competition is not so relevant in retrofits. We all have our equipment out there, and we need to find the best solution to serve our customers and make their vessels more efficient and competitive. And then, okay, I mean, it's also important to make a plan, to make a good action plan based on business cases. When to apply these solutions? When is the good time to apply these solutions, and when to introduce new fuels? And we have a team in our sales that is doing just that, looking at the vessel performance and having these strategic discussions with customers to make a tangible plan. So going back to the fitness, let's say, analogy, we want to be the personal trainer for our customers and help them reach their goals. So this is that. And of course, a personal trainer's obligation is also to train their clients safely without injuries. And in this respect, this is why we have a pragmatic approach to retrofits to cause the least disruption on an existing ship and let's say minimize also the risk of anything going wrong with the availability of the ship. But also with the safety in mind, because all these fuels are, as we discussed also earlier, a bit different to handle, and safety needs to be there. And also, the last point, as I mentioned, that a big thing for owners is to understand that, let's say, to know that the investment they made moved the needle and improved the situation as much as they intended to. And this is what we can do by really measuring the performance of the engine before the conversion and after. Thank you very much for your attention.
Thank you, Stam. 질문 혹시 있으시면 돼요. 빨리 오세요.
So, anyways, thank you so much for your good presentation. So I'm so impressed by your presentation. So, but as a vessel, a lot of things need. First, engine is okay. I accept you fully understand your just presentation. But as vessel, a lot of things need. For example, bunkering and storage, and also fuel supply system also. What should I do next other things you can do, or any other subcontractor? That's my question.
That is an excellent question. Thank you so much. Absolutely, especially when we talk about a fuel conversion on the ship, it's a vessel conversion. It's not anymore an engine focused conversion. And we have an ongoing project, which is our technology demonstrator. This is a publicly announced project with MSC, where there we are doing really interesting things. Actually, it touches about what Alfa Laval was talking about earlier, because there we're designing the whole systems around the engine, the fuel containment system, the fuel supply system, to be compatible with both LNG and ammonia, because we want to convert this vessel first to LNG and then to ammonia. And we want to do that by only working on the engine as much as possible and not on the surrounding systems, because of exactly what you pointed out, that we cannot just add systems to the vessel, and because the impact is great in terms of capacity and space and all that. And we also have a division in our within Wartsila, which is fuel gas supply systems, and they develop, of course, they have the LNG part, the methanol part, the ammonia part, systems that can handle these fuels, and also do, let's say, bunkering design and everything. But we also recognize that when it comes to retrofits, we need to work with partners here. So it is imperative that we work with repair yards, for sure. We have already been collaborating with repair yards for this project that I mentioned earlier. And we're generally open to work with partners, and even, these large projects, we expect that maybe the yard is the EPC provider or the turnkey solution provider in this respect, and they have also the freedom to get supply the systems by themselves, to procure the systems by themselves.
대대기업이요. 뭐 다른 질문 혹시 없으시면 알겠습니다. 수고해 주신 우리 와틀라 스탐에게 큰 박수 좀 부탁드리겠습니다. 감사합니다.